So we're going to look at the antiderivative, or what we call the indefinite integral. So undoing a derivative expression. Okay, we kind of looked at already that this is somehow related to area, okay, area under the curve, but it's not exactly quite clear what that relationship is. Okay, so we just want to make sure we're kind of clear what this looks like. So we want to we just want to focus on the antiderivative right now. We just want to undo a derivative. So here the big F is a original function, F is a derivative. So big F prime is F. So this is my derivative function. The antiderivative, big F, should have a power of 3. But if I differentiate this, I get 3x squared. Well, the x squared is fine, but we have an extra 3. So I'm going to divide by 3. Now, when we do this, we don't know if this was the original function because there could have been a constant which differentiated to 0. So we have to account for that by using that plus c. So looking at x, we know the power of the antiderivative must be squared. But if I differentiate this, I get 2x. I don't want that extra 2, so I need to account for it by dividing by 2. And then because we don't know if there's a constant there that differentiates to 0, we have to account for the fact that there could have been this plus c constant. So same thing here, we're going to antidifferentiate power 5 should started with power 6. If I differentiate this, I got an extra times 6, so I'm going to get rid of that extra times 6 with the divide 6. And then I can account for the fact that there could have been a plus c, so I need to make sure that the plus c is there. So that big F is our antiderivative function. Okay, and this is a notation we use for this. So the antiderivative f of x, that little integral sign, gives us big F plus c. So that integral sign, using the power rule, if we start with power n, we're going to increase that power by 1 and then account for that extra coefficient by dividing by that n plus 1 and making sure that we have a plus c involved there. And this is in the integral form. However, it's often written as a differential equation. So the derivative is equal to that. What's implied is we want the antiderivative. So we want to find the antiderivative y. So we get that using increase the power by 1. So this is just written in the same thing, but written in the differential equation form, where this is written in the integral form.